Hey guys, in this lesson we're going to really be starting to look at our quadratic roots, and I am going to do videos just a little bit differently right now just because life is kind of different right now and I have very limited time to work with you guys just because of that whole life thing. And so we're going to just try and simplify things so that I have actually more time to dig in with you when you get stuck instead of just making your videos, okay? So I'm just going to walk you through these notes. So go ahead and have out your notes that I've given you before we left campus and kind of follow along. So a lot of times you'll hear these things about roots, okay? So what is a root? So a root is the point at which the parabola, and remember, a parabolas are quadratic, so it's a curve that goes either down or it opens up. So the roots are where that crosses my x-axis, okay? And we only really care about the x-axis at this point. So you'll see here that it also can be called zeros or solutions or intercepts. So any of those four words that you hear really kind of mean the same thing. So you'll either hear roots or zeros or solutions or intercepts. You'll mostly hear those first two as zeros or roots. We'll get to solving them here in a little bit, but I want you to know that all four of those words mean the same exact thing. And it's wherever that quadratic crosses my x-axis. So the other thing to remember about that is whenever I cross the x-axis, my y value is 0. And we'll get there in a little bit of that's how we're going to be solving them, is setting y to 0. But for now, just remember that we're dealing with this x-axis and wherever it crosses. Okay, so there's three possible ways that my quadratic can cross the x-axis. I can have two solutions, which we'll see most of the time, and you'll see that right here. And this could be opening down too, right? If it crosses over once, it'll sometimes crosses over twice. I could have one solution where my vertex, remember that word, is where I change direction, where my vertex is actually on my x-axis. Or it is possible to not have a solution, because you'll see here that my vertex is above the x-axis and my quadratic opens up, so it'll never actually touch the axis. So let's look at this example. Okay, so find the solutions of the following quadratic equations by graphing. So remember, when I'm having you graph things, you can definitely always graph them by hand or plug them into Desmos, because it's really more important for me that you know what you're looking for when we're talking about solutions. Okay, so here, for this example, to graph this x squared plus 4x minus 5, we can go ahead and just make our set of points, starting with this -2. And I know that we want to start with this -2 because it's that negative b over 2a that you're going to hear a bunch from me. Or you could just use this in Desmos and see where it crosses my axis. So the same thing here. So let's go ahead and let me go ahead and open up Desmos and I'll show you what I mean on a couple of these. Okay, so now that I've got Desmos open, x squared plus 4x minus 5. So I just type that in, x squared plus 4x minus 5. So on Desmos, you'll see that it's really cool that you get these two little gray dots and they show you exactly where those points are. So I see that my two intercepts or roots or zeros or solutions, pick a word, right? They're all the same thing, would be at x equals -5 and x equals 1. So I can go ahead and write that. And the wording, how we would read this mathematically, is x equals the solution set of -5 and 1. Okay, so again, we can do the same thing. Use Desmos or graph this one by hand and do the same thing here. Okay, and we'll get to looking at some more of these in a little bit. So I really want you to just get really comfortable with finding these roots because that's the important piece here. Okay, so try out these ones too. Okay, so the discriminant, that's our next really big important thing. So the discriminant is something that we can do and use that will tell us how many solutions there are even before we start out. Okay, so that's how we can figure out how many solutions. So again, when I'm in standard form, and remember that's our ax squared plus bx plus c, our biggest exponent first going to our smallest and our alphabets in order, the formula for the discriminant is b squared minus 4ac. You'll see that again later, so don't forget it. So that b squared minus 4ac. I just plug that a, b, and c in, kind of solve it. I don't actually have to get all the way to the very end because all I need to know is it greater than 0? Is it equal to 0? Or is it less than 0? That's the key important piece for the discriminant. You don't have to actually know the actual numerical value. The important piece, greater than 0, equal to 0, or is it less than 0? So if it's greater than 0, that tells me there's going to be 2 solutions. If it's equal to 0, there's 1 solution. And if it's less than 0, there's going to be 0 solutions. Okay, so that's kind of just our important piece right now. So let's look at an example. So we're going to use the discriminant to determine the number of solutions. So in this number 7, I've got this written in standard form, right? X squared plus 5x plus 4. So my A is 1, my B is 5, and my C would be 4. So I've got B squared minus 4AC, and I plug in these values. If I was writing this, I would also have parentheses around this 5, because sometimes you'll have a negative, and you'll see that over in example 8. So I just plug those in, and I end up with a value of 9. Since 9 is greater than 0, I would have 2 solutions here. So looking at this one, and this is where parentheses come into a really big play and are really important. So I still have my B squared minus 4AC. So my B here is this negative 3. Don't lose your negatives. That's really important. So I've got negative 3 squared minus 4 times 1 times 10. So negative 3 squared is 9. Minus 40 is a negative value. It doesn't even matter what the value is. It's just less than 0. So I'm not going to have any solutions here. So now I want you to try these ones. I will post all of your the rest of these examples so that you have some time to look through them, or maybe I'll just leave them here and you can pause the video to go through them. And then it's time to just dive right into this homework, number 4. Okay, so here's where you're going to be practicing finding those zeros and those solutions and those roots. Definitely use Desmos to help you, because the important piece is that you understand what those roots are and those zeros are. Whenever you get stuck, just let me know and I can definitely help walk you through these things. You guys are awesome.